Hello and welcome to Scale AI with Ray on Vertex AI. We want to tell you about how easy it is to scale AI from laptop to cloud by bringing Ray and Vertex AI together. I know there are many other interesting and exciting sessions out there right now, but you choosing to be here means a lot to me. We wouldn't be here without you, so thank you for that. I'm Chris, product manager in Vertex AI, and this is?
Hi everyone, I'm Nina. I'm a software engineer at Vertex AI.
Now, how many of you guys have heard of Vertex AI? Raise your hand. Hey, keep your hand up there. Keep your hand up there. How many of you guys have heard of Ray? Wow, very cool. Now keep your hand up, keep your hand up. Keep your hand up if you are using Ray in production. Okay. Very cool. Thank you very much. I hope to see a lot more hands next year once we, let Ray on Vertex AI out there in the world, and you guys are using it. Well, I'm excited to tell you about Ray on Vertex AI. My team's been working really hard to show this to the world, and I'm very, very happy to tell you about it today.
Before we get into the details of Ray, we would like to provide you all with some context. First, I will walk you through an overview of Ray, then Chris will go through an overview of Vertex. Lastly, we have a demo to show you exactly how it works and how you can use Ray on Vertex AI. So what is Ray? It sounds like a lot of you here in the audience might know Ray pretty well, but for those of you who don't, I'll explain what Ray is all about. Ray is an open source, unified distributed computing platform for Python workloads, commonly used for ML workloads. Ray makes it easy to create ML flows in a distributed and parallelized way, and includes libraries to handle common machine learning tasks. So let's define some Ray basics and terms we will use throughout this presentation so that we're all on the same page. I'm going to start with the Ray cluster. A Ray cluster is a set of nodes that run Ray code. A Ray cluster can live on your laptop, on Kubernetes, or in the cloud. For our purposes today, our Ray clusters on Vertex will live on Google Cloud. Let's move on to Ray Core. Ray Core is an open source Python library for distributed computing for Ray applications. Ray Core helps parallelize and accelerate Python workloads. Lastly, we have Ray Air. Air stands for AI runtime. Ray Air builds on the distributed computing of Ray Core for AI and ML workloads, and provides tools for machine learning that include data processing, training, tuning, reinforcement learning, and serving. So I'll talk a bit more about the Ray cluster, which is made up of Ray nodes. We have two different types of nodes. Each Ray cluster has to have one head node and can have multiple worker nodes. Worker nodes run Ray code as well as distributed scheduling, and they each have their own object store. Our Ray head node has the same functions as the other nodes, but also additionally runs cluster management and driver processes for the worker nodes. Moving on to Ray Core, as I mentioned before, Ray Core is the low-level library for building distributed systems. Ray Core is made up of a few primitives like tasks and actors. Data objects are stored and passed between nodes in object references. Ray Core is really what makes Ray fast and efficient. Okay, I think that's enough definitions. Let's see what some Ray code looks like. As many of you know, the cool thing about Ray is that you can parallelize computation easily. For example, what I'll show you here is some image rotation. On the box to the right on top, we have a simple Python function to read an image from a file and rotate the image. We run this function on a list of image files, so the operation computes sequentially. Naturally, rotating a bunch of images in sequence can take some time. Moving to the bottom section here on the right, we're going to Rayify our code. We can do this with just a few small changes to achieve parallelized computation. The code will now run in a distributed way on our Ray cluster across our nodes in our cluster. In the blue, you can see that we add Ray remote in our code to indicate that this function is now Ray managed, and we will execute on the Ray cluster remotely and across different nodes. The function contents otherwise remain pretty much the same. Now, we've talked about the Ray cluster, we've talked about Ray Core, and we've seen how easy Ray makes it to parallelize code. Let's talk some more about Ray Air and show you that Ray Air makes efficient machine learning code just as simple as the Python code we just saw. Ray Air builds on top of the distribution power of Ray Core and adds simple libraries for Ray data, train, tuning, and serving. Ray Air code includes integrations with popular ML frameworks like XGBoost, TensorFlow, and PyTorch. I'm sure the audience sees some icons they might recognize in the left of this diagram. On the right, we can see examples of using Ray data to process a large data set and pre-process data. Next, we can see an example of Ray train to train an XGBoost model. We have Ray tune for hyperparameter tuning, and last we have Ray serve for deployment. All of these steps happen with just 2 or 3 lines of code. It's awesome how simple Ray makes machine learning. In our demo, we're going to show you how a similar flow runs on Vertex AI. Now that we've talked about Ray, I'll pass it over to Chris to talk more about Vertex.
Thanks, Ina. I want to tell you a little bit about Vertex AI and GCP's mission and how we fit into it. You might have seen this before. GCP's mission is to help accelerate organizations' ability to digitally transform its business. And one of the best ways I've seen customers achieve this goal is to deploy AI in real-world settings and enabling their businesses and their people to become AI creators. From infrastructure to train and tune your models, all the way up to trained AI agents ready-made for enterprise use cases, Vertex AI has all the toolings you need. Now, I want to take our focus to the AI platform and then look at it a little bit closer. AI platform includes the ML platform that provides the end-to-end managed MLOps experience, and in the green, building on top of that, an integrated Gen AI experience through Model Garden and Gen AI Studio. And we are continuing to build out and investing in this platform in 4 key areas. The data to AI experience to accelerate time to value, and the whole managed end-to-end MLOps experience to govern AI, scalable and open infrastructure, and lastly, provide state-of-the-art AI to help customers innovate. No matter where you are in your AI journey, you can find something useful in Vertex AI. Now, to put money where the mouth is about scalable and open infrastructure, we're investing not just in open source models, but also integrating with popular open source frameworks like Ray, so that you, as AI creators, can build and scale faster in your AI journey. Now, before we go into talking about Ray on Vertex AI, I have a little confession to make. In my LinkedIn, it says I have a master's degree in CS, but I gotta say, I barely just passed it because of this evil course called Intro to OS, Operating Systems. And I failed this class twice. I had to drop it out because one of the first homeworks that you do is you have to write parallelization code, distributed computing framework in C. And I could not figure this out. Now, this is when I knew that I could never be an engineer or be a data scientist like you guys. And I still don't know how to write this in C, but I can do this in Ray. So even if a dumb PM like me can parallelize my code, how much more can you guys do with Ray, right? And we're bringing this together with Ray and Vertex, and the power of Vertex and Ray together, so that we are providing these capabilities to you. And I'm so excited to announce publicly today, the Vertex is committed to support Ray as a first-class product. Ray on Vertex AI is 3 E's: easy to use, engineered for AI creators, and enterprise ready. And my team created this product with Ray users in mind, so that any existing Ray code can be used with just 1 line or minimal change. And you can see that on the top left in the ray.init, that all you have to do is provide a Vertex Ray target, and then you can connect and talk to the Ray on Vertex AI cluster. Now, let's take a quick comparison between the setup process of the OSS Ray and Ray on Vertex AI. Like any cluster or Ray cluster setup, you gotta do the basics. In the green box, that's non-negotiable. You have to set up your networking, IAM, and all the infra stuff that you have to do. Now, you still have to do additional steps by providing resources like VMs and disks, and start array, head, and workers in the nodes, set up utility functions like Jupyter Lab and OSS dashboard, connect to the logging, monitoring, and be able to collect all that information. And lastly, control your infrastructure costs through providing turndown commands and scheduling. And it's all fine and good. If you want to do all that work, that's more power to you. With Ray on Vertex AI, though, you do not have to worry about any of that stuff because we take care of all of these things for you. When you create Ray on Vertex a cluster through our Python SDK or UI, it already provides an integrated experience with Colab, cloud logging, cloud monitoring, and we even take care of the idle shutdowns and near zero scaling so that you don't have to worry about it. We made this so that you can focus on the most important aspect of your work, which is to be an AI creator. Now, they say a picture is worth 1,000 words, and I think a demo is worth 1,000 presentations. So we got 3 demos for you. So I think this demo is worth like 3,000 presentations. So Nina is going to show you how to create the Ray cluster through the UI, BQ integration, and lastly, a simple end-to-end XGBoost example. All right, demo time. Let me turn it over to you, Nina.
Thank you, Chris. We think that Ray on Vertex AI combines the ease and simplicity of Ray with the managed capabilities of Vertex. I'm gonna head over to our demo now. I'm going to show you 3 demos. The first one will be creating a Ray cluster. The second one will be showing you our native BigQuery integration. And the third one is going to be a full end-to-end machine learning flow. So let's start out with creating a Ray cluster. So I'm in our Google Cloud Console. I'm already on the Ray on Vertex AI page. But if you scroll down to Manage, you can also get to this Ray on Vertex AI page. From here, I can go ahead and create a Ray cluster. Setting up a Ray cluster is really simple. It only takes 3 steps. The first one is selecting a name for our cluster and a region. So I'll go ahead and do that. The second is choosing machine types for the head node and worker nodes that I described earlier in the Ray cluster. So here I can choose from different machine types. And I can also choose GPUs and accelerators if I want. Here's a list of some accelerator types. Can also choose disk types. Now, our worker pools correspond to the Ray worker nodes that I had discussed before. So here I can also choose machine types and accelerators and disks as well. The replica count corresponds to how many machines we have of each machine type. So if I had 3, I would have 3 worker nodes in this worker pool. I'll continue on to the third and final step, which is configuring security and networking. I can choose a service account if I want, and I can also connect to a network. So I'll go ahead and create this cluster. So while that's creating, you can see that it shows up as provisioning here. This can take a few minutes, so I'm going to show you some of the running clusters we already have. Showing you the specs of this cluster, we can see that we have Ray version 2.4 and Python version 3.10. We also have this machine type that I've selected, and in my worker pools for this cluster, I selected a V100 accelerator. Back on the main page, you can also see a button, Open in Colab Enterprise. We've integrated with Colab Enterprise to make interacting with your Ray cluster really easy. We have a Colab runtime template that provides a Ray version, Python version, and your networking already set up for you. Here I can show you a runtime template. You can see we have a bunch of them set up here with our networking, our Python version, and our Ray version here on the right. From these runtime templates, you can go ahead and create a notebook from scratch. But for the purpose of this demo, we've already preloaded a notebook for you. OK, so let's get into it. Now that I've created a Ray cluster, I want to go ahead and connect to it. So first, I'm going to set up Ray and our Vertex AI SDK. So I just ran that cell and initialized our Vertex AI SDK as well. Now I'm going to check that Ray is installed, and our Ray version is 2.4. This is the fun part. We're going to actually connect to our Ray cluster just using one line, Ray init. And we'll add in the address of that cluster we just created. So you can see it's connected. Our Vertex AI SDK provides the Python version, the Ray version of the Ray cluster, and a link to the open source Ray dashboard. This dashboard gives us more information about what's going on in your cluster, what jobs are running, how many resources are used. We also provide a link to our interactive terminal URI, and you can log on to SSH into a Ray head node to do some debugging. Moving on, now that we're connected, we can actually run some really simple Ray code on this cluster. So here I have a function to square some integers, and I'm going to do it in 4 parallel square tasks. I'll X out this button. You can see the output here, 0, 1, 4, 9. We also have a second simple function just to do a hello world and combine that with the squaring function. Okay, so that was the first part of our demo. From this part, you can see how easy it is to create a Ray cluster on the UI, connect to it in our Colab, and run some simple code. Now we'll get into the second part of our demo. I'm going to show you how we have integrated BigQuery seamlessly with Ray data. I'm going to run some setup here. Then I will get into Ray data BigQuery read. So what we do here is you can seamlessly read data from BigQuery into a Ray data table. Ray data needs a data source. Typically, open source Ray users have to use an existing data source like MongoDB, S3, or a CSV file. We read seamlessly from BigQuery, and we also incorporate the parallelism part of Ray data in our integration as well. This will take a few seconds to run here. Okay, awesome. It seems like it's done, and it only took 13 seconds. Next, we'll get into Ray data transform. We also support Ray data transforming here, and you can see that the mapping and shuffling functions of Ray data are also supported. Last, we will get into our Ray data BigQuery write. We can write back to BigQuery. People might want to do this after doing batch prediction or doing some data transformation. This also will take a few seconds. It's writing 569 rows here. Okay, that was pretty quick. And that's the second part of our demo. Moving on to the last and final part here, I'm going to show you a similar example to the Ray Air end-to-end machine learning flow we showed you before. I think this is really valuable because it shows you that you can use Ray Air machine learning code with very minimal modifications on Ray on Vertex AI, which makes it very easy to scale. So I already showed you how I loaded data from BigQuery, transformed it, and wrote it back. Now I'm going to use that same data source to prepare some data sets for our training of our model. So I'll run this. This sets up a training data set, a validation data set, and last, a test data set. Then I'm going to use a provided preprocessor from the Ray data library. I'll add in a standard scaler here, and that'll normalize my data. Now that we've done our setup, we can actually go ahead and train our model. So we're going to train a binary classifier here that has 30 input features in the input data. This is an XGBoost model, and this code was taken from the Ray open source documentation. So you can see, once again, how it seamlessly runs on Vertex. So this will, I think, take maybe 15 seconds. You can see it's going through some training here. Scrolling up just a bit, we included some XGBoost specific parameters, our data sets, and our preprocessor. Seems like this has finished already, and we've trained our model. Next step is RayTune. We can use RayTune for hyperparameter tuning our model. So I'll run these cells. This one takes a little bit longer to run, so I'm going to show you an output from a cluster we ran earlier today. You can see down here that we ran hyperparameter tuning on 5 trials, and scrolling down, we have 5 trials here with different train log loss and valid log loss. And once our hyperparameter tuning is complete, we're going to choose the best result and use that for our final model. Next, we're going to upload the model to the Vertex model registry. And register the model within Vertex AI. And this step can take some time, so once again, I'm just going to show the output. But once the model's in the model registry, we can just deploy it to an endpoint and then use it for live predictions. So in this output, you can see that we're creating an endpoint, and it takes a few minutes. And then once our endpoint is ready, you can see this endpoint object. Now this endpoint object is ready to be used for live predictions. So I'm going to pass in some test data. You can see this is what the data set looks like with 30 input features. Then I'm going to pass in a prediction request, and then our endpoint comes out with all of these predictions. So you can see that this last demo showed the full machine learning end-to-end flow. From these 3 demos, you've seen how we can create array cluster really easily, how we can integrate with BigQuery and array data, and lastly, how we can run that full machine learning end-to-end flow. I'll hand it back to Chris.
Awesome. Awesome. Thank you, Nina. It's not easy giving live demos. You did a wonderful job. Thank you so much. I really, really appreciate that. All right, so as you saw, Ray on Vertex AI is easy to get started and just get your code running. We have many native integrations that you saw from this code with Vertex and GCP products, and many more are on the way. Now, some of you may be wondering, how can I use this in my context, in my company? So let me tell you one example of customers that we talked earlier this year that we got to show Ray on Vertex AI, and they were really excited about it. And let me give you some context here. So how many of you heard of Dometic by any chance? There we go, we got one person, thank you very much. So Dometic, what they do is they manage customer supply chain. And they have these robots that you see that are running around in the warehouses, managing inventory, doing pick packing processes and whatnot. And they're doing something really cool. What they're doing with Ray is that they're training a reinforcement learning agent to be deployed in each of these robots to help their processes. And when I was showing them our roadmap and where we were going with Ray on Vertex AI, the Dometic team really found it exciting, and they're excited to use and are using us to scale up and to manage different RL agents for their use case so that they can serve their customers and help them deliver more value. All right, so to sum up our time together, I want to leave you with this. So if you remember nothing else from this session, I want to help you remember 3 E's. 3 E's, right? Easy to use, engineer for AI creators, enterprise ready. So easy to use, engineer for AI creators, and enterprise ready. As you saw through Nina's demo, using Ray to deliver end-to-end AI ops is easy. Now it's even easier with Vertex AI taking care of some of the setup burdens for you, so that you as AI creators can focus on what matters the most. Lastly, we want to make sure your most important work runs on a secure, scalable, and reliable platform, and Vertex AI is the place to do so. Preview version of Ray on Vertex AI will be available in September. We got some exciting integrations that are happening that I can't talk about just yet, but you'll find out through the preview refresh in Q1 and GA next year. Please check out amazing Karthik and Nenshad. Karthik and Nenshad, please raise your hand. The combo session in AIML 124. Please go to my boss and my boss's session so that maybe they'll give me some bonus points for getting more people in there. And please come check us out at the showcase booth. My good friends Ivan, Mikhail, and Sujit will show how to tune OpenLlama with PyTorch. But unlike Nenshad's Llama 2 demo, I think this Llama has a lot of drama because it's using Ray on Vertex AI, and I think that's a big deal. Well, thanks for the opportunity for us to tell you about Ray on Vertex AI, and see you at the collab session and showcase theater.